This is Farhat, and today we are going to talk about how to make a DIY Arduino which is going to make the LED blink. So to start off, we're going to begin with our PCB layout schematic. So in our schematic we can see the components which we used. First we used a diode 1N407. We used one voltage regulator 7805, another voltage regulator of 7833, an Atmega IC328. We used capacitors, both polarized and unpolarized. We have the crystal, which is gonna be of 16 mega, and we have LED aquas, resistors, and the pins on the sides which we are going to insert. We also have a barrel jack bar over there. So first we're gonna see in this upper circuit, the upper circuit works hand in hand with the lower circuit. So as for the upper circuit, we're gonna see that we have the two voltage regulators connected over here, and these help regulate us consistent 5 volts supply throughout the circuit. That's the function of the voltage regulators. Next we can see the capacitors. The capacitors will basically filter the waves which is produced by the oscillator. The oscillator is also known as the crystal, and once it filters, the noise reduction is going to reduce, so it's going to enable the functioning to proceed well. Next we have the diodes, and we have the LEDs up here, the resistors which help control the current, and the jack bar is going to provide the input to this circuit, which is basically gonna be like about 12 volts. Here next we have the Atmega IC328. So as we can see that it has the pinning systems on either side, and the reset button is connected on the low end by the 14th pin, and this is gonna be used to reset any code. So when any code is applied into this IC, it can be used to provide like different types of functions. So when the IC is programmed to a specific code, it's connected to the external circuit which just provides that specific function which has been set. Once you want to remove that code and reuse your IC again, then you'll have to press the reset button. So on the sides here we can see the input and the output pins. This basically is where we're gonna use in today's circuit. This specific one, we're gonna use these two ground pins over here and the 5 volts VCC. Basically to get the output, we're going to connect to the 5th pin, which will connect now to the LED. So the LED which we want to make it to blink, it's gonna be connected to the 5th pin, and we're gonna like function the output from here. So next we're gonna see the PCB layout design. In the PCB layout we have the we have the barrel jack here, and then we have our three capacitors. Two are gonna be polarized and one is non-polarized. On this other end we also have the capacitors on the lower circuit. So as you can see, this was our arrangement of the first circuit, this part of the circuit at the upper part, and we've neatly arranged the next part on the lower circuit and connected them simultaneously. Okay, so next we have this our pins where we're gonna connect the output, and we say they're connecting the 5th pin to the LED. The input pins here, and we have the grounds and the VCC. Here is where we're gonna place our IC. So once the IC is gonna be programmed, it's gonna be placed over here, and next to it we have the crystal. The crystal is which is basically the oscillator, and we have the resistors connected too. The connections are made on the Proteus. Once you design your PCB, make sure it's of the required size and all the wires are connected properly so that you have like proper current going through. Make sure the spacing is also well, so that once you reach your soldering stage, you don't have to go through all this like risk of short circuits or any connections which are unnecessary gonna be made. A small error might ruin a lot of things, so it's better to be safe. On the 3D visualizer now we can see how our components are placed physically. So we have our IC over here, the pins, the input output, where we're gonna give the power from. Then we have our diodes and our LEDs, voltage regulators, our capacitors, and our crystal, which is gonna be the oscillator over here. And we can see how we're gonna use external wires to connect these two circuits, which are gonna work together. This 3D visualizer basically helps a lot when you're gonna be done with your PCB etching and everything, and you want to place your components. So it's better to use your Proteus app for your schematic, which shows everything in details, to check if that your circuit is working well. Then your PCB layout is going to be printed, and you can also 3D visualize when you're placing your components for better accuracy. So next we're going to see step by step of how we're going to do this virtually. Like you're going to see the process step by step, and you're going to be able to like visualize it, and it's going to help in your project. So let's begin. So the first step over here, we can see that we've printed our design on a piece of paper. The paper should specifically be glossy or a butter paper, so that your PCB can be the design can be etched on the PCB, and it should be accurate, so that to avoid any open circuits or anything. So as you can see, you should apply like lots of force. That's like a tips to help you print your design well on the PCB. So once you print your design on the PCB continuously while pressing and heating, then you're gonna dip your PCB into FeCl3. So make sure the water you're gonna use is gonna be warm, and put the FeCl3 inside there and place your PCB inside, so that the etching process can start taking place. As you can see, the copper gets off at the end of the time, and you're left with the print on top of the PCB. The copper has all faded away. Now this print, we have to remove it. We're going to use the help of petroleum. You can use acetylene, but then petroleum is more convenient and readily available, so you just need to use a cloth and continue scrubbing it to remove the prints, to leave behind just the copper. As you can see, the shiny parts is now your circuit, which is the copper. Then now you have to, once we've obtained the shiny part and all the black print is gone and all your copper is set, no open circuit or anything short, you start drilling in your holes in accordance to your PCB design. So the drilling process takes place, and you use the drill machine to drill this. It's normally accurate, and it's gonna provide convenient holes. As you can see, we're almost done drilling in this process, and the holes have been formed for the components to be placed here. So in the next, we're gonna see where our components have been soldered onto our design. Okay, so we can see here we've placed all these components in place. This is our IC holder. We're going to place our IC here. After already set programming in, you have to bootload your IC, the Atmega 328, and place it inside the IC holder to be able to function. Next, we're going to have the capacitors and the voltage regulators, our two LEDs, resistors, non-polarized capacitors. This is our crystal. This is how it looks like in real life. And we have where we're gonna take the output from the 5th pin, and we'll connect this two grounds and this VCC to the 5 volts. The voltage regulator will regulate all that 5 volts. So as we can see, this is the end of our circuit. You may have to make sure it's neatly arranged and all the components should be placed. If there's any unnecessary components, there's no need. From the back we can see that we soldered our design well to all the holes and made sure like there's no any open circuit or short circuit anywhere. For this you'll have to use a DMM to check the continuity of the circuit. Once you made sure that everything is connected well and there's continuity where they're supposed to be, then you can just test your circuit in the lab with the proper power supply and everything, and with your external LEDs connected, wires and everything, and it's gonna work for sure, hopefully. So yeah, that's how we went through it. We saw the project design, the PCB and the 3D visualizer as well. We also saw the whole process of how to make this Arduino, DIY Arduino. We know that it's readily available, but now we finally know the process of how to make it ourselves. So I hope this video was helpful, and yeah, thank you.